we are going to look at still under ODE, ordinary differential equations, and it is about inverse D-operator. So under inverse D-operator, there is something that we have to do. We have an example here. Example of this, we have a question of this type. It should be which is equal to this. So what we normally do under inverse D-operator, we have to consider some things. Like for example, you have to know that your final solution should be given in terms of y complement, then you add it to y particular. So in our y complement, are you able to see that it is d second derivative of this plus 4 first derivative plus 4, then all these m should give us 0. On the complementary part, you equate it to 0 to know the roots of this function. So once again, let your d be m. So let's replace with m. It will be m squared plus 4m plus 4. Then this will equate with 0. We want us to see the roots of this function. So the roots of this function, are you able to see that which are the two numbers that once you multiply, you get 4, and once you add, you also get 4. So product sum method, and you get it is 2 and 2. So it means it will be m squared plus 2m plus 2m plus 4, and it is equivalent to 0. So taking m outside, now that it is common between the first two, we are getting 2 this, then plus 2, now that it is common, and m plus 2, then you get to 0. So you are getting it is m plus 2, m plus 2, and this one is also equal to 0. So the two roots are repeated. You can see it is m plus 2 is equals to 0. It means m is equals to negative 2. So our roots are negative 2. Remember, both of them are negative 2 since they are the same. And this one is just the repeated roots. Repeated. And on repeated roots, you can just write your answer in form of C1 exponent power your answer, which is just 2x, then C2 x exponential power negative 2x. So this is your y complement. So your y complement is that. So once again, you turn on the other side, and you have to know that under this inverse, D inverse, you normally take in your y particular, it should be 1 over f of x, which is now your function, this one. Then you are dotting it with your particular answer, this one that you are given, which is x squared plus 2x. Then when it is like this, it's like you are just writing this function, the one we are given here, this one here. So it will just be this. It will be 1 all over, it was d squared plus 4d plus 4, and all this you are just multiplying to this answer, which is x squared plus 2x. So when it is like this, what you normally do, you can rearrange it starting with the constant and the increase in powers of d, and your function will take this form. It will be 1 all over 4 plus 4d plus d squared. Then this we are dotting to x squared plus 2x. So what again you have to consider is that how can you make this constant, the one that we have decided to start with, to be 1? So are you able to see that we can just divide it all through by 4. So on dividing by 4, you get 1 over, now that 4 will be outside, just factor out 4, and you are getting it is 1, here it is 1 over, this one you can write it in form of 4d plus d squared over 4. Remember these ones, we have just let them the way they are, and this function we are multiplying with this answer, which is x squared plus 2x. So once again, once you have reached that point, let's now that it is about inverse. What is the inverse of this? You have to know that inverse of this, it is just x. So it's like you are just raising it up there, then it will take the bar. So once again, you still have your quarter there outside, and this one will just go there half. Get 1 plus 4d plus d squared over 4, but now it is inverse. Then this one you are dotting to x squared plus 2x. So this one, what you have to do, this inverse here, let's just put this one, the one is over 4 to be in a bracket, all this. So this one is affected by the inverse, simply because you know that inverse of 1 is 1. Inverse of 1 will always remain to be 1, but inverse of any other thing, it is affected. So once again, what you normally do, this sign here, it affects this the bracket here. Before bracket, this sign outside there. So what you get, it will be a quarter into 1. Now this one will change to be a negative number, since this inverse, because of that inverse. So minus what was in the bracket, it is 4d plus d squared all over 4. Then it is like this. Then since it is this minus something, it is this minus something, then the highest power of x is squared. It's like this one now is power 1. Then you are subtracting another something, which will be 4d plus d squared over 4, and this one is squared. So once again, this one, you are dotting this to our x squared plus 2x. So what are we getting? So you can just open the bracket very comfortably. That is, you are getting, it is a quarter into 1 minus, so 4d over 4, it will just be d plus d squared over 4, it will just remain to be d squared over 4 minus 4d over d. So this one you are squaring it, and on squaring, you are getting it is 16d squared. It is 16d squared, but this one is over 4 squared also, it will give us 16 plus 4d times d. How do you open this one using the long method? So when you are opening, you just get it is 8d, which is cubed over 16 plus this one will give us d power 4 over also 16. Then this one we are dotting with our x squared plus 2x. So once again, what you normally do, you just come here and check your answer, and you get it is up to the power 2. So once again, if you differentiate this function more than twice, it will just change to 0. So you just ignore these ones with the power greater than our function. So our function should go up to power 2. So what we are going to deal with, we are going to deal only with the one with up to power 2. So what is this multiplied by our answer there? Just be it will just be, it will remain. Anything you multiply by 1 will get that, just that thing. So it will be 1 times x squared. It will remain to be x squared plus 2x. But remember here outside we have a quarter. Then minus the first derivative of this. It will be 2x plus 2. So it is 2x plus 2. Then this one, second derivative of this, first derivative 2x plus 2. So second derivative will be 2. So it is minus now. Remember, 2. Then minus 16d squared. 16d squared over 16. So 16 by 16 is just cancelled. What's the second derivative of this? It will also be 2. And when it is like that, this is the final answer. You are going to multiply with a quarter. So it is 2x minus 2x. So when it is 2x minus 2x, that one and that one just go. And our d squared was over 4. And our second derivative, this one, was over 4. So it is just a half. This 4, this 4. The other one has just cancelled and became nothing. So these two and these two also disappears. So it will remain to be 1 over 4 into this is x squared minus this 2 over 4, it is just a half. Then the others as you have just cancelled off. Then so the final answer, this is your yp, will be, you can just write a quarter into this is x squared minus a half, and if you decide to open the bracket, it will be just x squared over 4 minus 1 over 8. This is your yp, but we said that your y should give us yc plus yp. But yc was the c1 exponent, but like this, plus c2. Remember, it was a repeated root, so there is the x, then exponent power negative 2x. Then this one we are going to add to this, which is x squared over 4 minus 1 over 8. And this is the final answer of y when we are just looking at inverse D operator. Thank you.